Hello, Sai Kalyan. How are you?
I'm fine, miss.
We'll wait for 5 minutes for others to join, then we'll start.
Okay, miss.
Hello, Vaishnavi, you didn't come last week. What happened?
Ma'am, I was not feeling well, ma'am.
Okay. So did you get time to go through the uh,
No,
PPT?
ma'am, I will do it in this weekend or the next week, ma'am, because I'm having my school exams happening now.
Okay, okay. So what are you having chemistry? When is chemistry?
On Monday, ma'am.
And chemistry, what are the topics?
First two lessons of organic, ma'am, like
So,
alcohols and phenols and
aldalkene.
haloalkanes.
So that you anyway know well, so no problem.
Yes, ma'am.
Okay. So please go through it because whatever I have taught early in the last class will be you will I mean the further will depend on that only. So in case you don't understand, just let me know. So we'll just do a few questions and that will give us some time for the others to join. So let us do these questions. Okay. Now, the first question, which cell will measure the standard electrode potential of a copper electrode? Who will answer this question? Which cell will measure the standard electrode potential of a copper electrode?
Is it option 3, miss?
Why it is 3? Why do you choose 3?
Because hydrogen electrode, miss, everything should be one bar in unity.
Yes, very good. So answer is 3 because it is a hydrogen electrode, and when you are measuring the standard electrode potential, all the values, that means the pressure of the gas should be 1 bar, and the concentration of H plus ion should be 1 molar, and the concentration of copper ions also, so that we can measure the standard electrode potential. So the answer is 3. Very good. Now the fourth one. Now somebody else please answer. You were there in the first class, Vaishnavi? Did you attend any of the classes?
First class I was there.
Okay. So you should be able to answer the second question. Difference between electrode potentials of two electrodes when no current is drawn through the cell is?
Cell EMF, ma'am.
Cell EMF. Very good. Cell
EMF.
EMF. EMF of the cell. Okay. Now the next question is standard electrode potential for half cell reactions are given, right? Two half cell reactions, the standard electrode potentials are given. There is a little error. Zn2, Zn2 plus. Fe2, Fe2 plus. Basically, let me write this is, if you see this, you may, okay, let me see if somebody can answer this. This is plus. Right? This part I can rewrite for you. Zn2 plus 2Zn. That is minus 0.76 volts. And Fe2 plus 2Fe. That is 0.41 plus 0.41 volts. Now you have to find the EMF of the cell. How will you do this react question?
Ma'am, option A.
What is the answer?
Option E.
Option
A.
A. A.
Ma'am, A, ma'am.
A. So what is the formula? The formula is E cell, E0 cell is equal to E0 cathode minus E0 anode. Now, what is the anode here? Where oxidation is taking place. This is the anode, right? According to this reaction, this is the anode because there the oxidation or the one which has a higher reduction potential. So that we should write. So what is the anode and what is the cathode? Now, what is the cathode? Cathode is where reduction is taking place. That is iron. So plus 0.41 minus 0.76. All right. So what will it become? 0.41 plus 0.76. So what is that equal to? Is it A or is it, what is it? Add and see. So what is the answer? Answer is D. Did you all understand why it is D? Hello? Who gave me the answer? See, children, you don't, you know, in spite of requesting again and again, you never switch on your camera. I have been told very categorically, I have been, suddenly they will come and inspect and they say, you are not strict. If they are not switching on the camera, ask them to leave the class. So I don't want to be strict with you children because I don't know what is your situation, whether your internet is working fine, whatever the reason is. If you can, please, what is the problem? I also keep my camera on. Why you cannot keep the camera on? I don't understand. I don't even realize who is answering. You want me to guess who is answering? Yes. Now, did you understand, all of you, why I got D as the answer?
Yes,
Okay. Now, the next one. Zinc granule is dipped into copper solution. Copper is precipitated. When zinc rod, you can say, is dipped in copper sulfate solution, copper is precipitated. Why? Can you tell me why? Why is copper precipitated? Look at the option. Both copper and zinc have positive reduction potential. Can that be answer? No. Reduction potential of copper is higher than that of zinc, right? Because reduction potential of copper is higher than that of zinc. That is a possible answer. Reduction potential of zinc is higher than that of zinc. That is anyway wrong wording. Both copper and zinc have negative reduction potential. So the only possible answer is B. The reduction potential of copper is higher. The one which has higher reduction potential is the one which gets reduced easily. And when copper 2 plus is changing into copper, what is happening to copper? It is getting reduced. So if copper is getting reduced, then obviously its reduction potential should be higher than that of zinc. Okay. Now let us do one more question. Now all of you carefully think of this question and tell me the answers one by one. All of you write the answers and then I will tell you the answer. All of you take 1 minute and write the answers. All the answers, this first one is question number 8 actually. So when they are referring, use the data given in question 8, it is this question given above. So find the answer of all these 3 questions. All the 3 questions are based on the first question. Please read and find the answer. Now tell me what is the question. Just take 2 minutes, all of you, and find the answer. And when you are answering, make sure your camera is on. Vaishnavi, are you sitting in the learning room?
No, ma'am, in my house.
Okay. Okay. So this you should be able to answer because you were present on the day 1. So you have to, or I don't know whether I taught it on the day 2. So using the data given below, find out the strongest reducing agent. So which is the strongest reducing agent? The strongest reducing agent is the one which has the lowest reduction potential. Okay. So the one which has lowest reduction potential will be the strongest reducing agent. Did you understand that? Reducing agent is the one which it gets oxidized easily, isn't it? So the one which gets oxidized easily is a reducing agent. So whichever has a lowest reduction potential. Now, which has a lowest reduction potential here?
Ma'am, is it chromium?
It is chromium. Answer is chromium. Then next one, based on this data itself, find out the strongest oxidizing agent. Which one will be the strongest oxidizing agent? The one which has highest reduction potential, right? So which has the highest reduction potential?
MnO4.
Yes, answer is MnO4. Here it is Cr and here it is M. Using the data in question 8, find out the option, in which option the order of reducing power is correct. Reducing power means whichever is the in the order of increasing power of reduction, or whichever in the order of which is the best reducing agent and least reducing agent. So reducing So you know already the one which is the strongest oxidizing agent. Choice number 2 is the correct answer. Why? Because you have already said chromium is the strongest reducing agent. So here, and Mn2 plus, that is the weakest one. Okay, so choice 2 is the correct one. Anyway, I'll send this to you. You should be able to.
Ma'am,
Yes,
for the before previous question, the second one, ma'am, strongest oxidizing agent. Why cannot be Mn2 plus, ma'am?
See here, you can see no increase in oxidation number, -2 plus. See what is given here is -2 plus. So this whatever is given here is the 3. We have to find the strongest oxidizing agent. Strongest oxidizing agent is the one which has the lowest. Strongest oxidizing agent is the one which has the lowest reduction potential, right? Which has the lowest reduction potential. So now here you see what is given here is MnO4 to Mn2 plus. That is the oxidation potential. Right? So if I reverse it, that is Mn2 plus to to MnO4 minus, then it becomes the reduction potential, then the values will become minus 1.51 volt. And that will be the lowest. See, all of them which are given here are not necessarily the oxidation potential, reduction potential. They are here, this one, what is given is the, what you call the oxidation potential. So that is why you have to reverse it and see, and then you will realize this has the lowest reduction potential, and the one which has the lowest reduction potential will be the strongest oxidizing agent. Convert all of them in reduction potential and then do it. See here, first one, minus to plus. This is also oxidation potential. Let us write here. So we should, to make it reduction potential, you have to write Cr3 plus 2 Cr2O7 2 minus, it is minus 1.33 volt. Then this is already reduction potential. So this is the same. So ECl2 and Cl minus 0 to minus 1. So this is reduction potential. So plus 1.36. And this one I wrote as reduction potential. So Mn2 plus E0, Mn2 plus, what happened? So Mn2 plus 2 MnO4 minus, so this is minus 1.51, right? And the last one is, this is also reduction potential. So E0 Cr3 plus 2 Cr is minus 0.74. All right, now all are reduction potentials. Now we have to find out the strongest reducing agent. The strongest reducing agent is the one which has the lowest reduction potential. Strongest reducing agent is the one which has the, reduce, see, the one which has, let me show you this one, then you will correct it. Here, this is the one. So this is here all are arranged in the order of increasing reduction potential, right? They are all in the order of increasing reduction potential. So the one which has a high reduction potential is the one which is reduced easily. The one which is reduced easily is a good oxidizing agent. And a good reducing agent is the one which has low SRP, or the one which has low SRP is the one which can get oxidized easily. Since it can get oxidized easily, it is a good reducing agent. So if you go, if you keep this in mind and then solve it, then where am I? So we have to find out the strongest reducing agent. Strongest reducing agent should be the one which has the strongest reducing agent should be the one which has the lowest reduction potential, right? So let us see which has the lowest reduction potential. Maybe I made the mistake in this one. So strongest reducing agent is the one which has the lowest reduction potential. So this should be, using the data given below, find the strongest reducing agent. Reducing agent is the one which has lowest reduction potential because it will get oxidized easily. The lowest reduction potential is minus 1.51. And find out which has the strongest oxidizing agent. Oxidizing agent should be the one which has highest reduction potential. Highest reduction potential is, oh, so I have made a mistake. So, so Cl minus, they have not even given that choice. I picked up this question from.
Ma'am, so the strongest reducing agent will be Mn Mn2 plus.
Yes, yes, according to that, strongest reducing agent should be Mn2 plus. But when you are looking at the, and since I've converted it correctly, Mn2 plus to MnO4, and then use the data to the strongest oxidizing agent. Oxidizing agent should have the highest reduction potential. So highest reduction potential is of this one. So Cl minus chlorine. So this is 2 and this is 1. Okay, give me a moment. Let me check the answers.
Yes, ma'am.
This is question number. Strongest reducing agent, question number 8. 8, 9, and 10. Question number 8, answer is 2. Question number 9 is 3. And question number 10 is 2. 2, 3, and 2. Okay, so there is something which is not correct. I let us leave it for the time being. I will discuss this question because there is something which I made some error in the question in copying it probably. Stop share screen.
Miss,
Tell me.
Miss, by seeing the E naught values, how are supposed to confirm there is a reduction potential or oxidation potential?
See the values which are given here, no? See, so you have to see, oh, they are ions. Sorry. See this, I just reversed it. They are ions. That is a mistake I'm making, sorry. See, you can make out whether it is oxidation potential or reduction potential by seeing the data on the ions, whether right. This is a mistake I was making. Good thing you pointed out. See here, you have to see what is the oxidation number of copper on the left and what is it on the right. So whether the oxidation, if the oxidation number is increasing, then it is oxidation potential. And if it is decreasing, then it is reduction potential. So here I just changed the oxidation. I looked at 2 minus and I didn't look at, it is the ion. So what is the oxidation state of copper on the left side? It is +6. So +6 to this Cr3 plus, so it is getting reduced. So this is the reduction potential. Here MnO4, so this is +7 to +2. So this is also the reduction potential. And here Cl2 0 to -1. So this is also reduction potential. And here Cr3 plus 2 Cr. So this is also, so all values given here are reduction potential only. Sometimes what they do is that they give values reverse, like supposing they may say E0, Zn2, Zn2 plus, they may give, right? And if they give like this Zn2, Zn2 plus, then what is happening? 0 to plus. So what is happening here? Oxidation. So if oxidation potential of zinc is given as 0.76 volt, then the reduction potential, which I will write reverse, that will be Zn2 plus 2 Zn, and then it will be minus 0.76 volts. So when I reverse it, right, so I can reverse the value. So I just looked at the charges and I thought this is 2 minus to 3. So I thought it is I didn't look at the ion, it was so small I didn't see. So they are all reduction potential values. Since they are all values of reduction potential, then you can say clearly. Now you can say which is the strongest reducing agent. Strongest reducing agent is the one which has the lowest reduction potential. So which has the lowest reduction potential? This one. this one has the lowest reduction potential. So it is CR. You said it right first, right? And
Miss,
whichever,
CR3 plus only should come, no, Miss.
which one?
CR3 plus option 3, according to you told. It's CR3 plus, but CR is minus 0.74, no, Miss.
Yes, you are right. CR3 plus should come. Whichever strongest reducing agent is the one which has the lowest reduction potential. So lowest reduction potential. So it should be CR3 plus. Correct. Then
Ma'am,
use the
can you
data.
explain that part, ma'am?
Huh?
Can you
What is
explain
it?
that part, ma'am? Like why it is CR3 plus?
Okay, let me take this table here. See, what happens is, one thing important is that we should always look at it in terms of only reduction potentials. Okay, so everything we are talking of is in reduction potential. Now, if all the values, if they are arranged in the order of increasing reduction potential, now the one which has high reduction potential means it can get reduced very easily. The one which has high reduction potential, what does it mean? It means it can get reduced easily. All right, it can get reduced easily. And if something can get reduced easily, what does it mean? It means that it is a good oxidizing agent, right? If something can get what does the oxidizing agent do? Itself, it gets reduced so that the other thing gets oxidized, isn't it? So for a good oxidizing agent, what does it do? It gets reduced and the other thing gets oxidized. So a good oxidizing agent is the one which gets reduced easily. Similarly, a good reducing agent is the one which can get oxidized easily, because I also told you the other day that whatever is the value of numerical value of SRP, if I reverse it, that will become the value of SOP. So if the value of SRP of any reaction is minus 2.92, then the SOP of that reaction will be plus 2.92, right? So the numerical values remain the same, the sign changes. So if I change the signs, then all the values will become the values of standard oxidation potential. Now, the one which has high oxidation potential will be the one which can get oxidized very easily. And if it is getting oxidized very easily, it should be a strong reducing agent. So which is a strong reducing agent which can get oxidized easily? Which one will get oxidized easily? Which has a low value of SRP? And which one can get reduced easily? Which has a low, which is the one good oxidizing agent is the one which can get reduced easily. All right. Now, did you understand this? So if I look at this, now I wonder why the answer is given wrong. Is there something else which I am not considering here? Right. So if I look at oxidizing, if I have to look at the data, which is the strongest oxidizing agent. Strongest oxidizing agent is the one which has the highest, strongest oxidizing agent is the one which has a highest reduction potential, isn't it? The one which has highest reduction potential. So which one is having the highest reduction potential? MnO4 has the highest reduction potential. So here MnO4, this is correct. Here it should be Cr3 plus, because Cr3 plus to 3R is the lowest reduction potential. So it's a strong reducing agent, and here it is strongest oxidizing agent because it has the highest reduction potential. Now here, if I arrange it correctly, then it should be Mn2 plus. Why they have given this one also, I am not able to understand. Cr in the order of reducing power. Okay, just leave this question because the answer is not matching what I think. We will leave it for the time being. I will come out with a solution and then tell you in tomorrow. Okay. Now let us, what happened? Now today we will start, we will do something which is relating to whatever. Okay, let us do this one question and then we will go to the next. Represent the cell in which the following reaction takes place. Represent the cell in which the following reaction takes place. Magnesium plus 2 Ag giving Mg2 plus 2 Ag. Okay. Calculate E cell if E0 cell is 1.37 volts. Now, somebody please do this question. First, E0 cell is given there. How will we do? First, let us write the cell reaction. What is the cell reaction? Can you write? Magnesium is getting oxidized. So we will write Mg2 Mg2 plus giving Ag plus 2 Ag. Right? This is solid. This is solid. This is aqueous and this is aqueous. Now we have to calculate if E cell. So the concentration of silver ions is 0.001. Concentration of magnesium ions is given as 0.130 m. Okay. We should also write the cell reaction. The cell reaction is Mg giving Mg2 plus 2E minus and Ag plus E minus giving Ag. I'll have to multiply the second equation by 2. So my cell reaction will become Mg plus 2Ag plus giving Mg2 plus 2Ag. Now, let us write who will tell me what is the Nernst equation? We'll have to use the Nernst equation, right? What is the Nernst equation? E cell is equal to who will tell me? Hari Raghav, can you tell me the Nernst equation? Hari Raghav, can you tell me the Nernst equation? Are you there?
No, no, yes.
Yeah, please tell me the Nernst equation. E cell is equal to?
Is it E0 minus?
E0 cell minus 0.0591 by N log of product raised to A divided by reactant raised to B. Now fill in the values. So E0 cell is already given to you there. So E0 cell is equal to 3.17 minus 0.0591 by N. N is a number of electrons that have been lost or gained. So that is equal to 2. Log of concentration of the reactants, products. What is a product? Have I written it correctly? Silver is 0.001. So what is the product? It is magnesium. So magnesium is 0.130 divided by 0.0001, the whole square. So who will calculate this quickly and tell me? Somebody? I think it should come to minus 0.21. And so the final answer comes to 2.96 volts.
Miss,
Yes,
the log values are not given. We can leave it in terms of log itself, no,
yes,
miss.
yes. If log values are not given, you can just leave it.
Okay,
If-
miss.
But sometimes they only ask you to write the Nernst equation for a reaction. They don't want you to do the calculation. So you can just leave it at this level. You can just leave it here. If the log values are not given, if log values are given, then you can. All right, so that you can do. Okay, so now we will start something new. And for that, we will write this Nernst equation. So Nernst equation is E cell is equal to E0 cell E cell is equal to E0 cell. What is happening? Minus 0.0591 by N log of concentration of the product raised to A divided by concentration of the reactant raised to B. Okay. Now, supposing there is a cell which is a cell which is represented by this reaction, zinc plus Cu2 plus giving Zn2 plus Cu. Okay, so there is a reaction like this happening. And in this reaction, what is happening is after some time, supposing the reaction ends up in equilibrium. That means initially the E0 cell here was 1.1 volt, and then slowly as the reaction progressed, the E cell becomes 0. So if a E cell becomes 0, there is no E cell is not there. So E cell becomes 0. You can say the cell is now in equilibrium. No reaction is taking place. So E cell becomes 0. When the cell is in equilibrium. So it reaches a state of equilibrium and E cell becomes 0. So if E cell becomes 0, then we can say E0 cell is equal to we can say E0 cell is equal to 0.0591 by N log of concentration of Zn2. What is the product here? Zn2 plus upon concentration of Cu2 plus. So that will be the E cell. Now, when the cell is in equilibrium, if you remember from last year, log of this, you have learned equilibrium constant. How do you for this reaction here, how do you write the equilibrium constant? Equilibrium constant K is equal to concentration of the product upon the concentration of the reactant, right? That is the equilibrium constant. So if the cell is in equilibrium, these values here, you can say they are the values of equilibrium constant. So I can say E0 cell is equal to E0 cell is equal to 0.0591 by N and log K. So you can find log K provided your cell is in equilibrium. So you can find the value of log K. So what will be log K? You can calculate and do it. So there is a small question which control. So this question let us try to do and find the equilibrium constant for this reaction. So if you have to find the equilibrium constant of the reaction, obviously you assume that the reaction is in equilibrium. So how will we find the equilibrium constant for the reaction? The reaction is already given there. First write E0 cell will be E0 cell will be equal to 0.0591 by number of electrons that have changed is 2, N is equal to 2, log of Kc, log Kc equilibrium constant. So how can you calculate Kc? Log Kc will be equal to, E cell is already given there. So log Kc will be equal to 0.46, which is already given there, 0.46 into 2 divided by 0.0591. Okay, and whatever value you calculate here, you have to take the anti-log. And if anti-log is not given, you can leave the answer as log Kc. Otherwise, the anti-log value of the solution will be given to you. So here, this part, if you calculate, it comes to around 15.6. So log Kc is equal to 15.6. So why I'm telling you this value is that the anti-log of 15.6, either that will be given to you or you can leave the answer as 15.6. So this is how you calculate. Sometimes they may ask you to calculate the equilibrium constant of the reaction based on the values that are given to you. So if you know the E0 cell of a reaction, you can calculate the equilibrium constant also of a reaction. So that is one. Then another thing that we associated to this, which is asked sometimes, is the Gibbs free energy of the cell. So delta G of a cell. So delta G of a cell is, the formula is minus N into F into E. The derivation of this formula I cannot tell you. Supposing the E cell is given, E0 cell of a standard, then you are calculating Gibbs free energy, standard Gibbs free energy. If E cell only is given, then you only calculate delta G is equal to minus N into F into E. Now this delta G you have learned Gibbs free energy, you have learned in class 11. So I assume you understand what delta G is. At least this much you should recall and remember that for a spontaneous reaction, delta G value should be negative. If delta G is negative, then the reaction will be spontaneous. So if you calculate E cell is given to you, you can calculate delta G. Sometimes it is called Gibbs free energy. Sometimes they may say how much is the work done by the cell. So the work done also is calculated in terms of delta G. Now this F value, what is F? F is the charge on 1 mole of electrons. I told you it is 96500 Faraday. F, coulombs. F is 96500 coulombs. 1 Faraday is 96500 coulombs. So N is the number of electrons that have changed in the reaction. So here again, there is a small question which will take care of all the things that we have learned till now. So let us try to solve this question. So what is the question? The cell in which the following reaction occurs, Fe3 plus 2E minus has E0 cell value is given. Calculate the standard Gibbs energy and equilibrium constant of this cell reaction. So how will we do that? I can tell you the okay. First, delta G you calculate. Calculate the Gibbs energy. So Gibbs energy you can calculate easily. Delta G is equal to minus N into F into E. Okay. Since we are using standard values, so we are already calculating delta G 0. So that is equal to minus how many electrons are changing now. You must calculate how many electrons. So for that, let us write the cell reaction carefully. So what is happening? Fe3 plus is changing into first let us write the oxidation. So I minus is changing into I2 and plus, so 2I minus is giving 2E minus. And next is Fe3 plus E minus is changing into Fe2 plus. So this equation I'll have to multiply by 2. So the value of N is equal to 2. So 2 into 96500 into 0.236. Tell me what is the answer. Children, when you are sitting in the class, at least something yes, no, something you should say, no? What is happening? Are you all there or not there? I don't even know. Are you able to understand what is happening here?
Yes, ma'am.
Sai Kalyan,
Yes, miss.
calculate. What is the answer? Tell me. Somebody has a calculator, please do it. And how will you calculate equilibrium constant? E0 cell is equal to 0.059 by n log Kc. So 0.236 is equal to 0.059 by 2 into log Kc, right? So you can say log Kc is equal to 0.236 into 2 divided by 0.059. Okay, so you can leave the answer in that format. So did you all, both of you understand how, all of you understand these two calculations, the two new equations that we have learned? Did you understand those? Only thing is you will have to learn the two new equations, which are based on which equation? Nernst equation. So the four equations that we have learned till now, have you all understood how to use them in a reaction or in a question? Tell me. All of you, please switch on your cameras and tell me what. Vaishnavi, are you understanding something?
Yes, ma'am.
What about you? Hariharan, today you didn't talk at all. What is happening? Hariharan, are you understanding something? Hariharan, are you there? Ashwin, are you understanding something?
Ma'am.
Yeah. Sai Kalyan, something are you understanding?
Yes, miss.
Okay. So now I will write down the four formulae that we have learned till now. What are the four formulae that we have learned till now? The first one is for E, if the cell is a standard cell, that is E0 cell. When is a cell a standard cell? A cell is a standard cell when all the reactants, all the concentration of all the solutions is 1 mole per liter, 1 molar, and the temperature of the cell is 298 Kelvin. So then it is a standard cell. So for that, reduction potential of cathode minus reduction potential of anode will give you the E cell. For a spontaneous cell, the E cell should be positive. All right. Then the other reaction related to this one is delta G. So delta G is equal to minus N into F into E. And if the value of delta G is negative, then the reaction, the cell will be spontaneous. Then the third is when the cell is not a standard cell. If it is not a standard cell, then E cell, then we can't call it E0 cell. E cell is equal to E0 cell. And this is a simplified version of the whole equation. So we can write 0.059 by N and log of product raised to its stoichiometric coefficient divided by reactant raised to its stoichiometric coefficient. That is the Nernst equation. And based on the Nernst equation, you have the fourth one where E0 cell, if the cell is in equilibrium, or E cell is equal to 0, when the cell is in equilibrium, then we can say E0 cell is equal to 0.059 by N log Kc. So you can find the value of Kc here. So these are a few things that I mean, like this is the last part of what we have to learn in this section. This is a long chapter. So the first part we have finished. The only thing which we have, which I need to clarify tomorrow is those two questions which for which we are not able to, because why the answer is not matching how they want the answer. But this aspect also you should understand clearly. High reduction potential, high SOP, high SRP, high standard reduction potential, high SRP means what? High SRP means means what? That means it can be reduced easily, can be reduced easily. And if it can be reduced easily, then what is the next thing you should understand? It's a good oxidizing agent. So the reactions which have high SRP, those reactions are the ones where your reagent is a good oxidizing agent. And low SRP means good reducing agent. Okay, so that you have to remember. High SOP is a good oxidizing agent. High SRP means good. High SRP is good oxidizing agent, and high SOP is a good reducing agent. Opposite. Okay. Now we will start something else. Now we will start comparing the next part of the electrochemistry that we have to learn. That is electrolytic conductance. Now here what we have to first understand is the difference between metallic conductors and electrolytic conductors. Two types. Okay, can you tell me how do metals conduct electricity? Anyone? How do metals conduct electricity? How do metals conduct electricity? How does the electricity flow? It is due to flow of electrons, right? So metallic conductors are those which allow the flow of electrons. So flow of their electricity is conducted due to what? Due to flow of electrons. Okay, because you know what is the bonding in metals? It is metallic bonding. So metallic bonding means the outermost valence electrons don't belong to only one atom. They are freely flowing. So since metals have free flowing electrons, they are able to conduct electricity. So metallic conductors, they conduct electricity by flow of electrons. Now, in contrast to that, electrolytic conductors in a solution, how is it that some solutions conduct electricity? Those solutions in the form of ion, due to flow of ions. Flow of ions. So the electrolytic conductors, they always conduct electricity due to flow of ions. So supposing I take three solutions. In one solution, three beakers, I have three solutions. In one, I have sugar solution. In the second one, I have salt solution. And in the third one, I have, acetic acid solution. So you will realize and I try to pass current through it. That means in a circuit, I put a bulb. Then if I put it in sugar solution, the bulb will not light. If I put it in sodium chloride, then the bulb lights brightly. And if I put it in acetic acid solution, the bulb lights, but it lights very dimly. So since the color of, since this indicates that the flow of current is dependent on the number of ions. So in case of sugar, there are no ions, so there is no flow of current. In case of sodium chloride, lot of ions, so current flows freely. And in case of acetic acid, it's a weak electrolyte, so not many ions, so the bulb lights dimly. So In case of electrolytic conductors, the current flows due to the flow of ions. Okay. One big difference in case of metallic conductor is that there is no chemical reaction that is happening, right? So there is no chemical change. Because of flow of electrons, there is no chemical change, right? But in electrolytic conduction, there can be chemical decomposition. So you have seen already in the galvanic cell that zinc changes into zinc 2+ ions and copper 2+ changes into copper. So you saw when I put copper sulfate, zinc rod in a copper sulfate solution, a chemical reaction actually took place. So when electrolytic conductor, in electrolytic conductors, when the current moves due to flow of electron, it can be accompanied by a chemical decomposition. There can be a chemical reaction that can take place. Then the third difference that you must have seen in in metallic conductors, some conductors show resistance to flow of current, right? Like when we take a tungsten wire and try to flow current through it, there's a lot of resistance there. That is opposition to the flow of current. So when there is resistance, then what happens? The wire gets heated up, and when it gets heated up, then white light it starts giving, and that is what happens in case of a bulb. So the resistance in case of metallic conductors, the resistance is because you should understand metallic bonding. So resistance is because these are this is one metal atom, this is another, and this is another. And these are the electrons in the outermost shell, right? So these electrons, not only, this is called the kernel, Kernel. So they have kernels, and the electrons, outermost electrons, are the ones which are responsible for flow of current. So these kernels can, the kernels in some cases, they allow free flow of electrons, some do not allow free flow of electrons. So they can cause resistance. The kernels, they cause resistance. But in case of electrolytic conductors, it is the the solute particles or the solvent particles, they cause the resistance. So there can be resistance in case of electrolytic conductors, but for a different reason, and in case of metallic conductors for a different reason. So that is a difference between electrolytic and metallic conductors. Okay. Main difference is that here it is due to flow of ions, and here it is due to flow of electrons. Now we'll do a little physics and apply it to chemistry. And since all of you are much better in physics than me, my physics is very poor, you have to help me now. So here we will talk about a few terms which we use here in this chapter also, since it is electricity related. So the electricity terms we will revise. So the first term is resistance. What is resistance? Tell me. Now, please, all of you speak up. What is resistance? Resistance is, tell me, opposition to the flow of current, isn't it? That is resistance. What is the definition of resistance? Anyone tell me? Sai Kalyan, what is resistance?
Opposing the flow of current. Yes.
Opposition to the flow of current. So you represent it by R. Okay, resistance is represented by R. And what is the unit of resistance? Somebody tell me, Hari Raga, what is the unit of R? Ohm. The unit of R is ohm. Okay, so you express it in ohms. Sometimes you can write it like this. So that is resistance. Then the opposite of resistance is what? Conductance. So conductance is what? 1 by R. Conductance is 1 by R, and the unit of conductance will be ohm inverse. Okay, we are coming to slowly conductance, so it can be ohm inverse. Then the third one is specific resistance. What is specific resistance? Specific resistance is the resistance, I mean, like first you say resistance is proportional to length by area of cross section, in directly proportional to the length of the conductor and inversely proportional to the area of its cross section. You agree? So R, if I remove this sign, then R is equal to rho L by A. What is rho? Rho is the specific resistance. So how do I define specific resistance? If L is equal to 1 centimeter and A is equal to 1 centimeter square, then what is R? R is equal to rho. So what is specific resistance? Specific resistance is the resistance of the wire which is 1 centimeter long and which has area of cross section 1 centimeter square. What is the, so I can say also rho is equal to R into A by L, right? Why I wrote like this? Because I want to arrive at its unit. So R is ohm and A squared is centimeter square and L is centimeter. So ohm into centimeter, right? So I need this first one and then this is the second one. Now this is in case of conductors, right? Now I want to translate it in form of electrolytic conductance. Okay, so what happens in case of electrolytic in an electrolytic cell? So, so supposing I have a electrolytic cell here and I have two electrodes. Okay, so one electrode is here and this is another electrode, right? And the area of cross section of this one is A centimeter square. And the distance between these two electrodes, this one is L centimeter, right? Then L by A, we call L by A. It is known as cell constant. For each electrolytic cell, this cell constant is a constant value. Whatever we do inside this cell, we have to make use of the cell constant. Why, I will explain just now. So this is a cell constant. Now, if I take, so what is the amount of liquid that will be, amount of electrolyte that will be present inside this? So if I show the two here, this electrode is here. This is the other electrode, right? I can make it like a cube. This is one electrode. This is another electrode. This is this area of cross section. This is A and this is L, right? Now, if this A is equal to 1 and L is equal, this is 1 centimeter. L is equal to 1 centimeter, and this is also 1 centimeter. Then what will A be equal to? A will also be equal to 1 centimeter square, right? So, so in this case, what will be specific resistance? Specific resistance, rho will be equal to R into L by A. We have just derived that here. A by L. So how much liquid is, how much electrolyte is there? So P is rho is equal to R into 1 centimeter square by 1. So rho is equal to resistance. So resistance, what is the resistance here? Of all the electrolyte which is present in this. So what is specific resistance of an electrolyte? Specific resistance of an electrolyte is equal to the resistance offered by all the ions present in 1 centimeter cube. What is the volume of this area? The volume of this area is 1 into 1 centimeter cube. So 1 centimeter square. So the volume is 1 centimeter cube. That is the specific resistance is the specific resistance of an electrolyte. Specific resistance of an electrolyte. Okay, electrolyte is the resistance offered by all ions. Resistance offered by all ions present in 1 centimeter cube of the electrolyte. We can say it present in 1 centimeter cube of the electrolyte, or we can say it is all the resistance offered by all ions present in an electrolytic cell, where the area of cross section, where the electrodes are 1 centimeter apart, and the area of cross section of each electrode is 1 centimeter square, right? So how much electrolyte will be present in this area? That is the resistance of the specific resistance of the electrolyte. So in case of when we want to calculate the specific resistance of the electrolyte, what we do is we try to find out the resistance offered by all ions present in 1 centimeter square of 1 centimeter cube of the, or 1 cc of the electrolyte. So that is called the specific resistance. Now we should come to the next thing. The next thing? The next thing that we have to understand is specific conductance. Specific conductance. Now, what is specific conductance? Specific conductance is the inverse of, so specific conductance is always, in chemistry, we measure it in terms of this, a long K. This is known as kappa. So that will be inverse of, so kappa is equal to 1 by rho, and that is equal to 1 by rho is what? R into A by L. A by L, and that is equal to, I can write it as 1 by R into L by A. 1 by R into L by A. So kappa is equal to 1 by R into L by A. L by A is, as I told you, is also known as a cell constant, which is a constant which is always given to you. So either you will be given cell constant, or the distance between the two electrodes and area of cross section of the electrode will be given. Then you can calculate cell constant. And using cell constant, you can calculate this value of kappa, or which is known as specific conductance. Okay, so what is specific conductance? Specific conductance is, you can write specific conductance is equal to conductance. 1 by R is what? Inverse of resistance, that is conductance into cell constant. So one of the values you have to use to find out the answer for specific conductance of an electrolyte. What will be the unit for this? Ohm inverse, ohm minus 1, and cell constant is L by A, so centimeter minus 1. Okay, ohm minus 1 and centimeter minus 1. Now the last thing, and then we will do 1 or 2 questions. The last thing is molar conductance. Molar conductance. What is molar conductance? It is the conductance of one solution which has a molarity 1 mole per liter. So molar conductance is represented by lambda m. So lambda m, how do you find out? It is 1000 into kappa. Why do we multiply by 1000? Because molarity is per liter. So kappa is in per centimeter cube. So you should multiply by 1000. So 1000 into kappa by molarity. 1000 into kappa by molarity. Okay, now we'll do 1 or 2 questions to understand this. So just 1 minute to copy one question. Okay, so these are a few questions. Let us try to do them. So 0.05 molar NaOH solution offered resistance of 31.6 ohm in a conductivity cell. If the cell constant of the conductivity cell is 0.367, determine the molar conductivity of sodium hydroxide solution. So how will I find molar conductance? Lambda m is equal to 1000 into kappa by molarity. What is kappa equal to? Kappa is equal to 1 by R into cell constant. Right? 1 by R. R is given to you 31.6. So 1 by 31.6 into cell constant is also given to you 0.367. Quickly find out. Do something. Tell me the answer. What do you get? This time, let us hope we get the correct answer. Today is not a good day. We are not getting the right answers. Do it. Did you get the answer, children? Is this sound coming from my laptop? Getting heated up. Hmm.
Is the answer 734 Siemens per centimeter?
You are not getting 232? Shall we? Yes, it is. Did you get the value of K? Kappa. 0.367 divided by 31.6. What is the value of kappa you got? 0.01,
0.0.
right? You got 0.012, isn't it? That's the value of kappa you got. 0.0116. So this is what you should get. Then you put this value there, lambda m is equal to 1000 into 0.012 divided by 0.05. So what will you get? 12
Oh my God,
divided,
20.
you got it? By around 240, which is close because we rounded it off here. All of you, all of you could understand this question.
Yes, ma'am.
In the same way, you can do all the remaining. You can see, read the next question. 0.02 molar KCl offered a resistance of 400 ohms. If the cell constant is 1.106 per centimeter, calculate the molar conductance. That also is the same similar question. The third one, you see, a conductivity cell has electrode 1 centimeter apart, and the cross section is 1 centimeter square. So you have to then calculate the cell constant. Cell constant is L by A. So 1 by 1. So cell constant is also 1, right? So then you can, if you know the cell constant and you know the resistance, then it will be, kappa will be 1 divided by 1.1665 into 1. And then find kappa, and then you can do the rest of this. It is 1 by 50 NaCl or m by 50, it is the same. In case of sodium chloride, because you all have not learned normal equivalent mass. Have you learned equivalent mass, how to calculate equivalent mass anytime? Vaishnavi, have you done equivalent mass anytime?
No, ma'am.
Okay, so then I'll have to take a class on that also. Okay, so Vaishnavi, you can leave. Thank you very much. Now I want to talk to the others. Please switch on your camera. Hari Raghav, tell me.
Yes,
How, please, will you go through the textbook to understand the lesson better? It is a little difficult chapter. You have to understand. You have to revise it, read it from the textbook, and tell me if you have any doubts or problems. Then I can help you, right?
yes,
If you all keep quiet in the class, it doesn't help me anyway. I don't understand whether you are understanding or not understanding what is happening. Okay, so you can also leave now.
thank you.
Hariharan, 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 are you there?
Yes,
I
ma'am.
didn't hear you at all today.
I had some Wi-Fi
What happened?
problems.
Some days you are very active, some days you don't talk at
Today
all.
only,
What
ma'am.
happened? Huh?
Wi-Fi problems.
Sai Kalyan, are you understanding the chapter? Is it difficult?
It's not difficult, Miss. I understand the chapter.
Yeah. And that question which I couldn't, where the answer given in the textbook and our answer is not matching, I will figure it out and we'll discuss it in the class tomorrow. Okay.
Okay, miss.
Okay,
Miss, and
then.
what about the test mark, miss? Did it change or
What is it?
the test mark, miss? Did it change or you told you will look after it?
I'll inform them. I have looked at it. I will change the test mark questions. I have not informed them yet. But yes, last test I had informed. This test I have not. I will tell them to change. Good that you reminded me. I had forgotten. Okay. Okay then. Bye.
Thank you, ma'am.
Right.